Rahim. Today we are going to learn about the conduction fibers and some terminologies of the heart, our cardiovascular system. This will be the last diagram of our today's lecture. Focus on this diagram. In the blue color, you can see the heart. This is heart. This is the atrium of the heart. The upper area is the atrium of the heart, and the atrium. You can see a node. This node is called SA node. This is called SA node. SA node. SA node is also called sinoatrial node. The sino is derived from the word sinus, and atrium for atrium. Atrial, because this is present in the atrium, that is why this is called atrium. While sinus represents the sinus venerum. Sinus venerum. Sinus venerum. What is sinus venerum? To know about the sinus venerum, we will focus on one of the diagram. Let's see this diagram. In this diagram, you can see the right atrium of the heart. This is the right atrium of the heart. In the right atrium of the heart, this is the tricuspid wall. This is the superior vena cava, which opens superiorly to the right atrium, and this is inferior vena cava, which opens inferiorly to the right atrium. And this happens actually in the mature heart. In the heart after birth of the baby. Before the birth of the baby, these two, the superior vena cava and inferior vena cava, combinedly opens to the right atrium, not separately opens to the right atrium. In the in the infant, not in the infant, in the fetus, when the baby is inside, when the kid is inside the womb or mother uterus, then the heart is not fully mature. When the heart is not fully mature, then the superior vena cava and inferior vena cava opens directly to the heart, and here is a sinus which that sinus opens to the right atrium. Only the superior vena cava and inferior vena cava opens to the right atrium in the form of a sinus, and that sinus is called sinus venosus. That sinus is called sinus venosus. But when the baby gets matured and is delivered from the mother womb, then the sinus is disappeared. The sinus venosus is disappeared, and that is replaced by a septum. That is replaced by a smooth area. This smooth area, in which the superior vena cava and inferior vena cava opens individually into the right atrium. That is no more called sinus venosus. That is then called sinus venerum. Sinus venerum. This is the sinus venerum. So the word sinoatrial node is derived from the sinus venerum and atrium. So this was the background of this word. Actually the SA node is present over here in the sinus venerum, on the upper side of the sinus venerum. That is why this is called sinoatrial node, SA node. Coming toward that diagram again. Now the second one, this is called SA node, which is present and with adjacent with the or which is present on the sinus venerum, which is present on the sinus venerum of the right atrium of the heart. Now you can see another node. This node is present adjacent with the interatrial septum or atrioventricular septum here. But this is actually present in the right atrium. This is also present in the right atrium, but adjacent with the interatrial septum and atrioventricular septum. This is called AV node. This is called AV node. This is called AV node or atrioventricular node. AV node or atrioventricular node because this is present and in the junction of the atrium and ventricle. That is why this is called atrioventricular node. Now coming toward the third diagram. In the third diagram, you can see the connection between the SI node and AV node, the conduction fibers between SI node and AV node. Coming toward the SI node again, the SI node is also called pacemaker. The SI node is also called pacemaker. We will learn about the pacemaker in the cardiac cycle. This is the connection between the SI node and AV node. These are internodal fibers. Internodal fibers. Internodal fiber. Three types of internodal fibers come from the SI node to AV node. Three types of conduction fiber are internodal fiber. This one is called anterior internodal fiber. This one is called middle internodal fiber, and this one is called posterior internodal fiber. Anterior internodal fiber, middle internodal fiber, and posterior internodal fiber. We will write it here. Internodal fiber are three types. Anterior internodal fiber, middle internodal fiber, and posterior internodal fiber. As the name indicates, this goes from the SI node to the AV node anteriorly, and this goes from the SI node to the AV node in the mid of the heart, and this goes posteriorly from atrium to ventricle. Now coming toward the next diagram. In this diagram, you can see the SI node. From the SI node, some other fiber also arise to the left atrium, and these fibers are called Beckman fiber. Beckman fiber. Beckman fiber. The Beckman fibers. Beckman is derived from the name of the scientist, and this gives signal to the right atrium, to the left atrium of the heart. These fibers give signal to the left atrium of the heart. Actually, the signal is generated in the SI node. The SI node are the pacemaker. This is called pacemaker because pace means speed and maker mean creator. So this is one of the property of the heart is automaticity. Automaticity mean to generate its own signal automatically, to generate its own signal. So the signal is generated in the heart by the SI node. This SI node generates its own signal. It do not require any foreign body to get signal. This generates its own signal, and that signal is transferred from the SI node to the AV node. That is also transferred from the SI node to the left atrium of the heart. Now from the AV node, this signal is from the AV node. You can see the other bundles arise, the fibers arise. This fiber from this area to this area. This is called bundle of His. This is very thick in size. That is why this, I have made it thick a little bit. This is SI node. This is AV node. This is internodal fiber. These are internodal fiber. These are Beckman fiber. And this is the from this area to this area. This is called bundle of His. Bundle of His. His was the name of the scientist, derived from the name of the scientist. Now you can see from the bundle of His, the left bundle branch arise and the right bundle branch arise. This is the left bundle branch and this is the right bundle branch. From this area to this area, this is the left bundle branch. From this area to this area, this is right bundle branch. So Now we will have to write on here the right bundle branch and left bundle branch. Now coming toward the next diagram, the left bundle branch further gave, this is the left bundle branch, this is the left bundle branch. The left bundle branch further gave two branches, this branch and this branch. The right one do not give any further big branch, and when the left bundle branch gave two big branches, this one and this one. Actually, the left bundle branch is from here to here, and this is the next branch of this one. So in this diagram you can see from bundle of his, the right bundle branch arrives, and the left bundle branch is from this area to this area. The left bundle branch gave further two branches, the posterior bundle branch and anterior bundle branch. Posterior bundle and anterior bundle, which gave signal to posterior area of the left ventricle and anterior area of the left ventricle respectively. In the next diagram, the right bundle branch and the left bundle branch gave further branches which have represented in the black color. These are called Purkinje fibers. Purkinje fibers. And these Purkinje fibers are the end conduction fiber, which are responsible for the contraction and relaxation of the heart. Now the signal is generated in the pacemaker in the SA node. That signal is conducted toward the AV node with the help of internodal fiber. That is also conducted to the right to left atrium with the help of Beckman fiber. That is also conducted to the bundle of his, then right bundle branch and left bundle branches, and the left bundle branch posteriorly and anteriorly. Then at the end, this is conducted towards the Purkinje fiber, and Purkinje fiber, when the signal reaches the Purkinje fiber, the Purkinje fiber gave that signal to the muscles of the heart, which eventually contract. What is the application of SA node and AV node? The SA node is over here to generate the signal. So what is the application of AV node over here? The application of AV node is that AV node is responsible for the delay of the signal. You can see from the SA node to AV node, the signal is conducted from the action potential is which is generated in the SA node, that is conducted from the SA node to the AV node. That is also conducted from the SA node to the right to left atrium. Now, meanwhile, when the signal goes from this area to this area, or when the signal goes from this area to this area, during the conduction of the signal, those areas of the heart get contracted. During the conduction of signal from the SA node to AV node or SA node to the left atrium, each area of the heart is contracted in the atrium. I'm talking about the atrium. Each area of the atrium is contracted during the conduction of the of the signal from SA node to AV node. But when it reaches the AV node, there is a delay of the signal. When the atrium get relaxed, then after a few portion of second, this signal is conducted toward the bundle of his. So the application of this, if there was no AV node, now you will understand it properly. If there is no AV node, then the conduction of signal will be uniformly from the SA node to the bundle of his and to Purkinje fiber, and there will be combined contraction of the atrium and the ventricle. So to avoid the combined contraction of the atrium and the ventricles, the atrium and the ventricle should be contracted separately, individually. So during the conduction of signal from this area to this area, the atrium get contracted. Meanwhile, the signal is delayed or relayed over here for few seconds, for few, no, not for few seconds, for few portion of seconds. Okay. When the signal is conducted after relaxation, the signal is conducted from AV node to these areas. So this is the application of AV node is the conduction, the application of the AV node is to contract the atrium and the ventricle separately or individually. This is the next diagram. No, not this is the next diagram. In this diagram, I have explained this diagram time and again, so you will bore from this diagram. Um, this is heart, this is aorta, and this is aortic wall. This is aortic wall. So we will learn a few terminologies over here. First terminology is systole. Systole is also called systole. Systole is actually the contraction of the atrium. The contraction of atrium, no, not atrium, the contraction of ventricle is called systole or systole. The contraction of right atrium or left atrium is called systole. Systole is the contraction of right and left atrium, right and left ventricle. The contraction of right and left ventricle, right and left ventricular contraction is called systole. And another terminology is diastole. The relaxation of right and left ventricle. Now the heart rate and the heart rate as the name indicates, this is the systole and diastole of heart per minute. You can also say that rate of contraction and relaxation of heart, that is what we call heart rate. Generally we measure the heart rate in minute. In 1 minute the heart rate is generally considered as 72 beats per minute. 72 beats per minute is considered as heart rate. 72 beats per minute or 72 contraction and relaxation per minute is generally considered as the heart rate. If the heart rate is above, the normal heart rate should be from 60 to 100. If this is above 100, then this will be called tachycardia. If this is below 60, then that will be called bradycardia. The heart rate above 100 is called tachycardia, and the heart rate below 60 is called bradycardia. Now another terminology is the stroke volume. Stroke volume. What is stroke volume? Stroke volume is actually the volume of blood pumped by the ventricle in each stroke, in each beat. Volume of blood pumped by each ventricle in one stroke or beat. That is called stroke volume. Stroke mean beat. Stroke mean the contraction of ventricle. Stroke mean the contraction of ventricle. So stroke volume mean the volume of blood pumped by each ventricle in one stroke. Stroke volume, in stroke volume we generally represent the volume of blood pumped by the left ventricle of the heart in one beat. The volume of blood pumped by the left ventricle of the heart in one beat, that is called stroke volume. In one beat, the volume of blood pumped by the left ventricle, that is called stroke volume. The stroke volume is the value of stroke volume is 70 ml. This is just the average. 70 ml is the stroke volume. With each stroke, with each beat, the left ventricle pump. With each beat, the left ventricle pump 70 ml of the blood from the left ventricle to the aorta. Now, coming toward the next one, the cardiac output. Cardiac output. What is cardiac output? Cardiac output is actually also, this is also called minute volume. Minute volume. In definition, we will write it here. The volume of blood pumped by the left ventricle in 1 minute. The volume of blood pumped by the left ventricle in 1 minute, that is called cardiac output. How will we calculate the cardiac output? Normally, the cardiac output for the calculation of cardiac output, cardiac output CO, cardiac output is equal to heart rate into stroke volume. Cardiac output is equal to heart rate into stroke volume. So once again, cardiac output is equal to heart rate. What is the heart rate? Normal heart rate is, for example, 72 is the normal heart rate, multiplied by stroke volume. What is the stroke volume? 70 ml is the stroke volume. So the cardiac output will be 70 into 72. We will have the calculator. 70 into 72, that is equal to 5040. It means that this is represented in ml. It means that this is cardiac output is nearly equal to 5 liter. 5040 ml is nearly equal to 5 liter. So the cardiac output is 5 liter. Cardiac output is 5 liter. Our minute volume is 5 liter. It means that in 1 minute the heart will pump 5 liter of blood, and in 1 minute cardiac output will be 5 liter. It means that this left ventricle will pump 5 liter of blood in 1 minute. And you will be surprised to hear that the whole human body contain only 5 liter of blood. So from where this 5 liter of blood will come? This 5 liter of blood, which have been pumped from left ventricle to the aorta, and then goes into the capillaries and back to the right atrium of the heart, and from right atrium to the lung and back to the left atrium, and from the left atrium to the left ventricle. So this is a whole cycle. This is just the cardiac cycle. um, so this 5 liter of the blood is circulated again and again, and in each minute the heart will pump 5 liter of blood, and that 5 liter of blood is actually the cardiac output. In the various heart diseases, we also measure the volume of blood pumped by heart in 1 minute. From that, we deduce some diseases and some other pathological condition of the heart. So these were a few. Were few terminologies. Another one terminology: freeload and afterload. What is freeload and afterload? Freeload and afterload. And these are very important to learn. Freeload is actually the, you will write definition by yourself. Freeload, when this ventricle, when these ventricles are when the left ventricle of the heart, or when both the ventricle of the heart get relaxed, when these ventricles are filled with the blood, when both the ventricles are filled with the blood, both are combinedly filled with the blood, one from this area and one from this area. So when both the ventricles are filled with the blood, at that time the pressure of blood against the wall of the ventricle, at the end of relaxation, the pressure of blood against the wall of the ventricles at the end of diastole. At the end of diastole, when the ventricle is completely relaxed, when the ventricle are completely relaxed, or when the ventricle are completely filled with the blood, at that time the pressure of blood against the wall of these ventricles is called freeload. It's called freeload. These are called freeload, and the volume of freeload, or the pressure freeload, is measured in the millimeter. The freeload of the left atrium is left ventricle. Freeload is equal to 30 millimeter of Hg, while the right ventricle preload is equal to, that is 7 millimeter of Hg. 7 millimeter. In the right ventricle, the pressure of blood against the wall of the right ventricle is very low, that is 7 millimeter after at the end of the diastole, and here that is 30 millimeter of Hg when the ventricle is completely filled with the blood. Now coming toward the after, what is afterload? Afterload is actually in the freeload we will measure the pressure of blood against the wall of the ventricle. In the afterload we will measure the pressure of blood against the wall of the aorta. Over here, when the you know that when this ventricle contract, this blood goes from this ventricle to the aorta by opening of this aortic wall. So before the opening of the aortic wall, the pressure of blood which is needed to expel the blood from left ventricle to the aorta, that pressure of blood is called afterload. Afterload is actually the pressure of blood needed by the left ventricle, to pump the blood to the aorta or the pulmonary trunk. The pressure of blood needed by the ventricle to pump the blood to the aorta or the pulmonary trunk. So the pressure of the blood needed uh, when the pressure of the blood over here in the ventricle is increased from the pressure of the blood in the aorta, then this blood will be pumped from this area to that area. So torsi, then when the pressure of the blood in the ventricle is increased from the pressure of blood in the aorta, then the contraction will take place, and at that point when the pressure of the blood in the ventricle is increased from the pressure of the blood in the aorta, so that at that point we measure the afterload. Afterload is actually the pressure of blood in the aorta or the pulmonary trunk. The pressure of blood in the aorta or the pulmonary trunk, that is called afterload. That is actually the pressure needed to overcome this pressure, to the pressure needed to pump the blood from the ventricle to the aorta or from the ventricle to the pulmonary trunk, which I have not made over here. So in the afterload, the the left ventricle afterload is equal to that is equal to 80 millimeter of Hg, 80 millimeter, while the right ventricle afterload is equal to that is again that is very low, that is 20 to 30, that is 30 millimeter of Hg, 30 millimeter of Hg. So it means that the pressure of blood uh, at the end of diastole, when these ventricle get relaxed at the end of the diastole, the pressure of blood in the aorta or the pulmonary trunk. In the aorta, the pressure of blood is 80 millimeter, and the pulmonary trunk, the pressure of blood is 30 millimeter. So that pressure of blood, which should be overcome to pump the blood from the ventricle to the aorta, that pressure is actually the afterload. That is 80 millimeter, and that is over here in the pulmonary trunk, that will be 30 millimeter, but that should be after the aortic wall or after the pulmonary wall. Okay, for today this was sufficient, I think.